Hi, everyone, and welcome to day 2 of Launch Week. Launch Week is a tradition that we started in 2024, and it has been so fun getting to share every quarter new things that we've built with all of you. This week, I'm at Embedded Worlds, where I'm going to be talking to many of you, I hope, sharing more about Memfault and showing off many of these new features to the world. But today, we're going to go over them in details, and I'll be very excited to not only tell you what we've built, but also show you a little demo. By now, if you've been following us, you know some of the themes of what we talk about. Building hardware is hard, and embedded devices break all the time. Hardware bends, it rusts, it wears out, it breaks. But of course, it's not just the hardware. Software also breaks. And so what makes building these connected devices so hard is that hardware quality alone is really hard. Software quality alone is really hard. And trying to do software and hardware quality together is really the hardest. And so inevitably, as we build these devices, put them into the world, they sometimes break. The hardware breaks, the software breaks. But how do we know when it happens? And how do we know what the problem is? Do we ask the customers? They rarely give us the right answer, right? I have memories of looking through customer support requests back when I was working on the Pebble Watch. And oftentimes people just sent us a 2-line email that says, it doesn't work, the battery sucks. Okay. Not particularly helpful, is it? So we might try and reproduce it, but reproducing it may take thousands of hours. Consider a bug which happens once every 10,000 hours. If you have 10,000 devices out there, it happens every hour. But if you're trying to reproduce it in the lab, good luck. And so what most of us do, if we can get our hands on it, is look at the logs. This is where I started most of the time. When I was looking at a customer support request, we had the foresight to make the Pebble iOS app at Pebble collect all the logs from the watch over Bluetooth and attach them to the customer support email, so that at the very least we'd have logs. And you know what? Oftentimes it helped me get to the bottom of things. It's a very powerful tool. Logs do contain great data, but they're not the end all be all of observability. Certainly, as I mentioned, I've used log many times at Pebble. At Memfault, we regularly inspect our own server logs to improve our service. But logs often contain data that isn't relevant. They aren't always exhaustive enough. Logs are about as good as your implementation. Finding exactly what you're looking for is time consuming. You're grepping through raw files, sometimes even across multiple files. They only work retroactively. And of course, they only let you look at one instance. So they're not a really good solution for fleet monitoring. They don't tell you anything about the scale of a problem. Which means that after pouring through megabytes of logs, although you may find a smoking gun, you've wasted lots of time, you might have gotten pretty frustrated, but you did get there. You still, in terms of understanding the scope of the problem, you're still just about halfway there. You don't know whether this is a one-off issue that requires to just be handled at the customer support level, or if this is a massive issue that all of your customers are encountering. So you don't yet know the scale of the problem, and therefore you don't really know what you should do next. There has to be a better way. And so at Memfault, we started by building observability, right? We started with observability, including metrics and crash reports, because we really had this fleet-wide view in mind. But we asked our customers, and they were pretty clear. They still rely on logs for their work day in and day out. And what do they want? They want to be able to search through all their logs at once. In fact, here's a quote from them directly. I would love to be able to search through all my logs at once. You have no idea how much of my day is burned examining logs one at a time. So we didn't have to guess. So what if you didn't have to waste all this time trying to track down the logs from the time the device crashed? What if you had them all at your fingertips and you could filter out the noise and get straight to the information you needed? What if you could do this fleet-wide and quickly see how often the problem occurs? So not just understand what the problem is, but how big of an issue is this really? That's what we built. And as you know now with Memfault, not only did we build it, but we optimized it for devices. As I mentioned, this has been one of the number one requests for our customers for years, and we wanted to take the time to build it right. With Memfault Log Management for devices, you can automatically collect your logs, search them all in one place with detailed filtering capability, and enrich them with contextual data, all within the scope of your device. Log management and analytics from Memfault connects all your logs. It, of course, correlates this data with all of our other observability data on the fly. So that means your metrics, your crash reports will all be shown in context with the logs. You'll be able to use log analytics to analyze trends over time. And you can, of course, search across all your logs fleet-wide in one place. Memfault is the only log management solution optimized for devices. This is what makes us unique. Our log management system is lightweight. It does not consume much memory, code space, bandwidth, or battery powered. It is device aware, so it understands devices at a very low level. We even, on some chipsets, integrate with specific features of the SoC you're using to build your product. It works with intermittent connectivity or even non-IP connectivity, whether that's a device that's plugged in via USB to a PC, or a Bluetooth device talking through a gateway, or proprietary wireless protocol, or of course, LTE connectivity. It is integrated into a single device SDK with logs, metrics, traces, faults, and OTA update management, so that you do not need to include 100 different pieces of software to do the work you need to do and to manage your devices. And of course, that SDK is available for MCU, Linux, Android, all kinds of devices in a single package. So when a problem occurs, you can just pull up the device in Memfault and check out its logs. You can look at those logs in context of the device data to get to a root cause, filter out all the noise, and identify the problem. Then with one click, you can get a list of all the other affected devices and search for that log file log line across your fleet. This is a big change from the workflow I was mentioning earlier. We're no longer downloading a bunch of log files from some storage server and grabbing through them one at a time, getting frustrated, having no idea what the overall impact is. We can all do this within the Memfault platform in a few clicks and get insights not just into one problem, but into the behavior of the whole fleet. With log management in Memfault, you will save days, sometimes even weeks of time whenever you need to investigate a problem. And your existing logs, the logs you're already collecting, become not just an insurance policy against issues, but rather a tool for fleet-wide insights that you can use to understand the behavior and the performance of your fleet alongside your observability data. All right, so let's see it in action. So here's my Memfault dashboard, the one you already know and love. You see every time you log in into Memfault. And so the first thing that we're going to do is we're going to pull up a device and see what we can learn from its logs, or at least look at its logs. I'll click on my device lists. Here, what we'll have is our device inventory, an incredible feature which many of you already know, which lets you look at any of your devices across the fleets, search all the devices by some criteria, and investigate them in more details. I'll click on one of those devices. And here, of course, we have some information about what software it's running, what hardware version it is. But for the sake of this demo, we're going to look at this new tab on the device page, which says device logs. So let's click on it. And we'll look at the last 30 days of logs for this device. All right. So here you can now see we've got hundreds of lines of log that this is a microcontroller based device connected over Bluetooth, so it doesn't upload a ton of logs, but we see hundreds of lines of logs. And of course, we can now start searching. So let's search for BLE. And here we have super quickly all of the log lines which the device emitted when it was trying to connect via BLE to its companion device. Excellent. So that's already an amazing workflow, and one that I'm sure you'll start using regularly. But this is just the tip of the iceberg. What makes Memfault Log Management so powerful is the integration with the rest of our observability data. So I'm going to go back to our dashboards. Here we go. And now what I'm going to do is I'm going to look at one of our issues. We've got a number of issues that happen a lot. Click on one of them. And now what I'm going to do is, first maybe share a little bit about this issue. So here we have an assert. So our device was trying to push some data. It's collected some accelerometer data, processed it into some fitness data, and it's trying to push it to the companion device, let's say. So something in the Bluetooth stack, perhaps, or in the data storage. This issue started happening 10 days ago, and it's already impacted over 100 devices. So what we see here is we now have logs attached to this issue. So I can click on trace logs, and what you'll see is we're back to our log view we saw earlier on the device page. But instead of having the all of the search terms that we had earlier, now the trace ID is pre-populated. So we're looking only at logs that happened around the time this issue was seen. And we can start looking at them. So we see that there's an error level log right here that tells us an assert fails. Okay, that makes sense. It happened around the same time we collected the trace. So far, so good. But I think what's interesting in these logs is the next line, where we're trying to sync a data buffer, and it looks like the address of the buffer is 0, which is pointing at a null pointer error. Let's look to see if this happens often. At the moment, this could just be a correlation, right? Maybe this happened and it's fine. Sometimes the buffer is 0. That's okay. And maybe this is actually correlated to our issue. So first, we're going to search for this null buffer condition. And we'll see that it happened only once in the logs that were collected alongside this trace. So, and this is where it gets really, really cool. I'm going to go and search all the logs for all the devices that experience this issue. So I can click on extend to all logs for this issue. I'll click here. And now what the Memfault log engine will do is look across all the devices in our fleet, find the devices that experience this issue, and collect and look at the logs around the time this issue happened, and search them for the same search that we were just looking at. So you'll notice that we've now moved into what's called issue logs, because we're looking at all the logs for a specific issue, not for a specific instance of the issue. And we can see that we have we see this log line replicated many, many times. We'll extend the time frame to 30 days just to get really all the data that we can. And we see now we've got hundreds of instances of this issue, of this log line seen. And we can start seeing some stronger signs that this is not mere happenstance, because we see that 100% of the devices that experience this issue see this log line. And 100% of the time we see this log line, we experience the issue, right? So Memfault has already identified those correlations. So this is starting to tell us that this is really likely this null pointer exception, or this null pointer in our data, in our logs, is likely part of the root cause of this problem. We can look further and click on this distribution pane, and we'll see that indeed, this log line is seen with this issue on one software version, one hardware revision. It's a very narrow set of circumstances. And we can click on the overtime chart to look at, when the issue started happening, and how often we see this log line across the whole set of devices that have this issue. This is a really neat view. We can look at the data, the number of instances of the specific log line. We can look at it distributed across cohorts, or the number of devices that have seen the log line, and we can even group it by software version. Of course, here there's only one software version that experiences the issue. So in all likelihoods, that the charts are not going to tell us a lot more. But I find these log statistics and log analytics to be a really, really helpful tool in trying to figure out what's correlation, what's causation. All right, so I think now with log analytics, we were able to convince ourselves further and further that this is at the very least very strongly correlated. But the last thing I'd want to know is, do we see this null pointer log line when devices are operating normally? And to do that, we can once again extend the search to even more devices. So I'll click to extend to all logs. And so what happens here is that we are looking at the same log search, but across the entire fleet during the same time period. And right away, what we'll notice is that the actual number of instances, our log count chart, hasn't changed much. So it means that whether I search for devices that see a specific issue or my whole fleet, I get about the same number of log lines matching this, null buffer. So that's an even stronger sign that the two are related. And in fact, if I remove the null in my search and I just look for this buffer address search, I'll get a lot more instances, almost 2,000 of them, starting earlier and spanning more software versions, as I can see in my distribution. So in fact, devices that don't have the issue prints the same line, but with a non-null buffer, and devices that see the issue prints the same line with a null buffer. So using log search and issues together, looking at our distributions and our counts over time, we were able to get a pretty good sense of the root cause of this bug. This is a hugely powerful feature. We just scratched the surface, and I hope you find it as exciting as I do. Let's get back to our slides. Memfault, as a reminder, is the only embedded device observability solution that includes monitoring, debugging, observability, and now log management. So you can find issues, you can fix them, you can improve your products using data-driven approaches to product development, and you can push updates to your fleets all in one place with a single SDK on all of your devices. This is all delivered with our universal SDKs. They work on any hardware, any operating system, any connectivity, and with any other cloud provider. Whether you want to see metrics from a low-power sensor running FreeRTOS, you want to see logs from your AOSP device, or you want to collect crash reports from your local Yocto Linux endpoints. You can see it all under one pane of glass on the Memfault platform, which includes our SDK, lightweight, collecting these metrics, these score dumps, these logs, these reboots, and software version information. Our intelligent data routing, which can push this data to the cloud over very complex multi-hop and non-IP connectivity links. And of course, the high scalability Memfault infrastructure, which collects this data, reassembles it, and provides all the analytics and visualization for it. I hope this first demo got you excited about log management and about Memfault. You can find out more at memfault.com/log management. And I hope you'll also follow us along on social media or join us at Embedded World to talk about it. I'm happy to hear from you anytime. Bye, everyone.